Okay, so we are taking an in-depth look or a closer look at the hydrologic cycle. Now, the section that we're actually going to take a microscopic view of or a real in-depth detailed look at is this part here. Okay, so far most of our focus has actually been spent on the stuff that you and I can see. There's a very important component to the water cycle or the hydrologic cycle, and that's the stuff that happens underground. Okay, so I want to go ahead and again review two terms that you guys went over when we were in lab, also through bookwork: porosity and permeability. Porosity essentially is how much open space, how much pore space there is to hold a liquid. Now, if you recall back to lab, we tested this by taking a dry material and saturating it, and then measuring how much liquid that material was able to hold. Okay, that amount of liquid we calculate as a percentage. That would be percent porosity. Permeability, on the other hand, now that's a measurement of how quickly water is able to move through a substance. Now, a substance with a high permeability is a substance that transmits water very, very well. The gravel, for example, had a high permeability. Most of you found that the water moved through that relatively rapidly. Whereas the tighter packed sand didn't transmit water quite as well. It didn't let water flow through it as easily. And so for that reason, the sand had a low permeability. Now, here's a picture that I think exemplifies permeability quite a bit, because permeability also deals with the interconnectedness of the waterways. How much water is able to flow through at a given time. So looking at this picture of permeability, you can see that the water is able to flow. There are a lot of interconnected passageways and pore spaces that are connected that allow the water to flow. Now here's a picture of porosity. Again, high porosity would be something that has a lot of open space, whereas something that doesn't have quite as much open space or isn't nearly as porous would be low porosity. Okay, high porosity holds a large amount of water. Low porosity holds a low amount of water. So moving on, we have a series of groundwater terms that you guys are going to be accountable to know. Okay, now I'm going to go very quickly through these because you guys can pause this and copy the notes down as need be, but I want to have these for you. Okay, so groundwater, obviously water that's stored in the ground, intuitive. Okay, aquifer refers to the rock body that actually stores, and the key part here is transmits water in usable amounts. This means that the water is stored not only, but is also transmittable, or is able to move fast enough and recharge fast enough that they were able actually to draw the water out of that aquifer and use it for drinking water, bathing, etc., for our uses. Okay, now the water table is the area that is the top of the saturation zone or saturated zone. Okay, and we're going to give you two more terms, and then I'm going to show you what these look like. Unsaturated zone is the area of an aquifer that's non-saturated. Okay, this does not have damp or wet water in it. It's actually relatively dry. Some books and some people will call this the vadose zone. That's just for your information. If you come across that term, that's what they're talking about. And the saturated zone is, like I said, the area that is saturated with water. Okay, and lastly, referred to or relative to these is the capillary fringe. The capillary fringe is the area above the zone of saturated water or saturation that has a slight dampness to it. The water has been pulled up into that because of capillary action. Now, I'm going to go ahead and exit out of that for a second because I want to show you guys what this would actually look like. So the terms that we talked about, like we said, were the water table, okay, the saturated zone, the unsaturated zone, okay, and the capillary fringe. Okay, so just to show you guys what these are, I'm going to label it on this sheet that you guys have as well. Okay, water table is actually already labeled for you. That's the line that separates out the saturated zone from the unsaturated zone. Water table says that everything below it is considered saturated zone. Okay, everything above that is considered unsaturated. okay? And then, like we said, the area in between the saturated and unsaturated, just above the water table, we have the capillary fringe. This is the area where it's damp, okay? So that there is the capillary fringe. Now, back to our terms, there are more to add, okay? Other components of this would include an ordinary well. Now, this is essentially a hole in the ground, okay, that reaches the zone of saturation, excuse me, and this is what we say is equilibrated with atmospheric pressure. What that means is the water table reaches up to, or the level of the well reaches up to the water table, okay? If it's above that, it's a different type of well, and that would actually be considered an artesian well, okay? An artesian well, however, is when water is drilled and pressure is released, which means the water is actually pushed up above the zone of saturation. It's pushed up above the water table because there is artesian pressure causing that. Okay, now artesian wells are caused by confining beds, which is an area of low permeability, doesn't let water flow through it much. It almost acts like a cap on a jar or a lid that restricts the flow of water. Okay. Also associated with this terminology is confined aquifer. This is an aquifer that is not open to flow freely. It has an aquifer with a barrier above it, okay, and below it. So like I say, this is like a jar with a lid on top. And we've talked before, this is the type of aquifer that produces artesian wells, okay? Unconfined aquifers, on the other hand, are aquifers that provide ordinary wells. Okay, this is like a jar with no lid on it. So these will produce ordinary wells. So what I'm going to do is I'm actually going to show you again what these terms look like on paper. And I forgot the last term we're going to look at here is what we call the potentiometric surface. Okay, this is the surface at which the water level will rise to in an artesian well when drilled to. Okay, so this is the surface, like I said, the depth or level that the water is pushed to when it's under pressure. Okay, this one makes more sense if I show you an actual diagram of what this looks like. So I'm going to go back here. Okay, so what we have here, these are the terms that we've gone over. Okay, ordinary well is just exactly that, a well that's at atmospheric pressure. So this here is an ordinary well. Okay, because it's at the water table. Whereas this well here is pushed above the water table. That means that this is an artesian well. This is why Fiji charges so much for their water. They've claimed their water is better because it comes from a artesian well. Okay. Now, by the way, talking about these two types of wells, the ordinary well is associated with an aquifer, okay, that is unconfined, which would be this here. Again, here's our confining layer. Here's our unconfined aquifer. Okay, this unconfined aquifer is held up by this confining bed. This is a layer of low permeability, low porosity. It doesn't transmit water well, so this is a confining bed. Or sometimes we call it a layer as well. Okay, and the confining bed or the confining layer always sits atop of the confined aquifer, this here. Okay, so again, artesian wells drill down to confined aquifers. These are under pressure because they're confined by a confining bed. These are unconfined aquifers associated with ordinary wells. These are equilibrated at atmospheric pressure. They rise to the water table. Lastly, we have this thing called potentiometric surface. And again, I told you defined, this is the surface at which water will rise when drilled to because of artesian pressure. And so if you'll notice, there's this dashed line that lines up with where the artesian pressure reaches. This right here is the potentiometric surface. Okay. Now these are all of the different terms for the water table. Okay, I want you guys to actually practice going over these. And so what I'm going to have you do is flip to the back side where you guys haven't filled this out yet. Okay, this is a blank diagram. This is exactly what you're going to be doing on a test. What I want you to do is hit pause. Okay, hit pause, and I'm going to go over this, or actually just put up a solution set to it, but I want you to pause it and test yourself first. Hit pause. If you haven't hit pause yet, you're cheating. Hit pause. Alright, so here's your solution set, starting with water table. Okay, that's this line here, and so I label it as such water table. Now the area just above, that's the slightly damp area, that's called the capillary fringe, and then everything above that, which I used with this bracket here, so this area is unsaturated. That's the unsaturated zone. Okay, now everything below our water table, again, like I said, is considered saturated. It's the unsaturated zone. Okay. Now, let's take a look at our wells, because that's usually the next place I go when I'm trying to identify these things. And I go ahead and I find the ordinary well right away, the one that is equilibrated at atmospheric pressure. And I know relative to that will be an unconfined aquifer. So that's this layer of water right here that's accessible and usable. That's from an unconfined aquifer. Now, I go to my second well, and sure enough, it rises up above the actual layer that it penetrates. That means it is an artesian well. Okay, artesian wells are pushed up by the potentiometric pressure, and this dashed line that I actually added in is the potentiometric surface in this situation. Okay, now these artesian wells are formed by the confining bed that is above the confined aquifer. And actually, I just realized I goofed up. That's not right. This here is the confined aquifer. Okay, so the confining bed is above, and actually in this case below as well. Okay, so confining beds above and below, confined aquifer, artesian well. Those are the 10 terms that you guys are going to be able to and need to be able to identify for our assessment come Thursday. Again, as always, if you have any questions, concerns, comments, email me. Lastly, I have posted the notes that I put up using that PowerPoint, so you have access to that as well on this page. Happy studying. Make sure you come back on Thursday prepared for this assessment.